Alright, welcome folks. Today I'm going to do a little lesson for you on pH and pOH. So these are logarithmic scales that relate the concentration of either an acid or a base to its strength. If you recall from chemistry, concentration is like the amount of a certain thing, so in this case acid or base, in a given unit volume. So we normally measure concentration in moles when we're doing acidity. So we look at how many moles of a given acid or base there are in 1 liter of solution. Okay, so let's talk about what an acid or base actually is. So if you take just normal water, the molecules will react in the following way, and really this should be a double arrow because this is an equilibrium. But what happens is water molecules will react with themselves to form H3O plus and OH minus. So let's kind of take a look at what that looks like. So here we've got 2 water molecules, and what's happening here is the bottom water molecule is grabbing a hydrogen from the top water molecule. And so basically what's happening is the lone pair of electrons on the oxygen are bonding with that hydrogen on the molecule above, and then the electrons that were in between the oxygen and hydrogen are moving in to form another lone pair with the oxygen. And so what we end up with is hydroxide, which is missing a hydrogen and has a negative charge, and hydronium, which has an extra hydrogen and a positive charge. And so hydroxide is the one up on top, and hydronium is the one down on bottom here. Okay, these are some formulas that we're going to use. There's basically 4 quantities that we need to know about a substance when we're talking about whether it's an acid or a base, and that's the pH, the pOH, the hydronium concentration, and the hydroxide concentration. And from those values we actually get 4 equations here. So the pH is the negative log of the hydronium concentration, the pOH is the negative log of the hydroxide concentration, the pH plus the pOH will always add up to equal 14, and the hydronium concentration times the hydroxide concentration will always equal 10 to the negative 14th. And so if we know any of these quantities, like say the pH, for example, if you just knew the pH, you could use that to solve for all the other values that we're missing. So let's I have a visual on the next slide here that will help us do that. So again, the 4 quantities that we need to know about are hydronium concentration, hydroxide concentration, pOH, and pH. So if we know the hydronium concentration, we can calculate the pH using this equation. pH equals negative log of hydronium concentration. Similarly, if we know the pH, we can figure out the hydronium concentration with this equation. And we can do basically the exact same thing with the pOH. The pOH is the negative log of the hydroxide ion concentration, so we can use that equation to go back and forth between pOH and hydroxide ion concentration. So note that in chemistry, the letter P, when it's used like this, actually means negative log. So in this case, pH means negative log of hydronium, and pOH means negative log of hydroxide. Okay, and then if we want to go back and forth between the pH and the pOH, those values will always add up to equal 14. So we can use that equation if we know pH to get to pOH or vice versa. Similarly, if we know the hydronium concentration, we can figure out the hydroxide concentration using this formula. Hydronium times hydroxide is 10 to the negative 14th. This one's a little bit less useful. I use this equation probably the least of the 4. But if you're comfortable with it, you can use this one to go from hydronium to hydroxide or vice versa. I tend to use the other 3 more. Okay, And so these are the four equations all written together. This would be a good slide to take a screenshot of if you're watching this video. This will be very useful as you're working through these problems. Okay, and then this is a slide just showing you like various substances and where they sit on the scale of pH. So note that this is pH 0 down here, and these are things that are very acidic, like battery acid or stomach acid or lemon juice or vinegar. On this side, we have things that are very, very basic or not acidic. So like liquid drain cleaner, caustic soda, bleach, oven cleaner are examples of things that are very basic. Note that if we flipped this scale, it would be the pOH scale. So battery acid has a pH of 0, it would have a pOH of about 14. And similarly, liquid drain cleaner would have a pOH of 0 approximately. Okay, this would be another good slide to take a picture of or take a screenshot of. You don't have to know the entire table, but it would be good to know at least a single column on this table. But essentially what this table does is tells you, if you're looking at any of the quantities that we're going to be looking at in this lesson, like hydronium concentration, hydroxide concentration, pH or pOH, and it will tell you, if you know that number, whether the substance is an acid or a base. So for acids, they have high concentration, and that means greater than 10 to the negative 7th moles. High hydronium concentration. Low hydroxide concentration, so less than 10 to the negative 7th moles. They'll have a low pH, so less than 7, and they'll have a high pOH, so greater than 7. So what does this mean? Well, if you look at a substance and its pH is less than 7, I think this is probably the most important one for you to know. If the pH is less than 7, then it's an acid. Similarly, for a base, if the pH is greater than 7, it's a base. And you can also use these other quantities to determine whether it's an acid or a base, but this is the one that I think is the most important to memorize, the pH. Okay, let's go through an example. All right, so stomach acid has a pH of 1.5. What is the pOH of stomach acid? Okay, so let's figure that out. Well, we know that the pH plus the pOH equals 14 from the formulas on the previous slides. So I'm going to put in 1.5 for the pH. Then I'll subtract 1.5 from both sides, and that will get me a pOH of 12.5. Okay, pretty easy. What is the concentration of hydronium ions in the stomach? Well, for that one, we're going to use the formula pH equals negative log of hydronium ion concentration. And I know the pH is 1.5, so I'll say that that's the negative log of the hydronium ion concentration. To solve this for the hydronium ion concentration, you first divide both sides by the negative, right? By -1 to get rid of that negative sign. So then we would get -1.5 equals the log of the hydronium concentration. Remember that this log is base 10. So then after we divide by the negative sign, then we're going to take the left side of this equation and put it in the exponent of 10. So we'll end up with 10 to the -1.5 power equals the hydronium ion concentration. Okay? And then you just type this into Desmos, it'll spit out an answer. So I get 0.032 molar equals the hydronium ion concentration. For answers that come out like this, where it gives you a bunch of numbers, what you're going to do is you're going to write down all the zeros in front, and then as soon as you get the first number that's not a zero, you'll write that number, and then the number that comes after it with proper rounding. So we call these two numbers that come after the zeros significant figures. So I want all of your answers on this quiz written with two significant figures. All of your answers that look like this. Okay, what if we want to solve for the hydroxide ion concentration? Well, it's a very similar formula, but now we're taking the pOH, which we solved for in the first problem, And we're saying the pOH equals the negative log of hydroxide ion concentration. So then we divide by the negative sign, convert the logarithm into an exponent, and we'll get 10 to the negative 12.5 equals hydroxide ion concentration. And then we type that into Desmos, and we'll get 3.16 times 10 to the negative 13 m equals hydroxide ion concentration. So when you type the answer that's in scientific notation into Desmos, you're going to round the coefficient to the hundredths place. So 3.16, 6 would be the hundredths place, space, and then a lowercase x for times, space, 10, and then you'll use the caret symbol. So that should be on your 6 on the keyboard, and then negative 13. And then the m should already be written. Let me know if you have questions on this. I can help you with this. Okay, and so then I'll also ask a question about whether or not it's an acid or a base that you're looking at for the given substance. This one's really obvious because it's stomach acid, so we can tell it's an acid. But let's say I didn't tell you that this was stomach acid. Let's say it was just like an unknown solution. How could we tell, looking at these numbers, that this is an acid? Well, the easiest one to look at is the pH. The pH is 1.5, and that number is less than 7. We could also look at the other numbers. So the pOH is greater than 7. That also says that it's an acid. The hydronium ion concentration is greater than 10 to the negative 7th. So that tells us that it's an acid. And the hydroxide ion concentration is less than 10 to the negative 7th. Negative 13 is less than negative 7. And so we could say that this one is an acid also from any of those things. I think the easiest one to look at is the pH. Okay, one more example. The concentration of hydroxide in household bleach is 0.0079 molar. What is the pOH of household bleach? What is the pH of household bleach? And what is the hydronium ion concentration of bleach? Is bleach an acid or a base? Okay, so we'll start with the pOH, and for that one we're going to use the formula that relates pOH to hydronium ion concentration. So we're just plugging in 0.0079 for the hydronium ion in the formula. We're calculating this in Desmos, negative log of that value, and Desmos will spit out the answer, which is about 2.1. For your pHs and pOHs, for most of the problems in the quiz, you're rounding to the tenths place. Okay, so that should be fairly easy. You're just taking this number and plugging it into the formula for pOH. So then now we're going to figure out the pH. Remember, pH and pOH will always add up to equal 14. So I'm just going to say plug in the 2.1 for pOH, and then we're going to solve for pH. Subtract by 2.1 on both sides of this equation, and you'll get 11.9 is the pH. Okay, nearly done. Last problem, figure out the hydronium ion concentration. So now I'm saying 11.9, because that's my P. Oh, shoot, this one has a mistake in it. Here, I'm going to fix this real quick. Okay, give me 1 second here. Because this one was asking for hydronium ion concentration, but I had hydroxide through here. So we need to make sure that I'm staying consistent here. Okay, so let's go back to this slide. So I know my pH is 11.9, and so then that's equal to the negative log of the hydronium ion concentration. So then I'm going to take 10 to the negative 11.9, right? And I remember I got this by dividing by -1 and then raising both sides to the 10th power because this is log base 10. And that gives me the hydronium ion concentration, which is 1.62 times 10 to the negative 12th. Okay, and then is this an acid or a base? Well, if we look at our pH, it's greater than 7, and so that tells us that it's a base. We could also tell it from the pOH, which is less than 7, the hydronium ion concentration, which is less than 10 to the negative 7th, right? 10 to the negative 12th is less than 10 to the negative 7th, or from the hydroxide ion concentration, which is 0.0079. Okay. Last example, a car battery is dripping acidic solution. When tested with a pH meter, the solution... Oh, whoops, you wouldn't test that with a pH meter. You would titrate it to figure that out. I'll fix that later, though. The solution from the battery had a hydronium concentration of 0.158 molar. What is the pH of the solution? What is the pOH of the solution? What is the hydroxide ion concentration of the solution? Okay, so we'll start with pH. We're taking the negative log of 0.158. When we do that, we get a pH of 0.8. So we're just taking 0.158, the hydronium ion concentration, plugging it into the formula for pH. We get a pH of 0.8. Now we'll calculate the pOH. 14 equals 0.8 plus the pOH, which is 13.2 when we subtract 0.8 from both sides. Okay, last up we need to figure out the hydroxide ion concentration of the solution. So now we're going to take 13.2 and we're going to plug it into the formula for pOH. So this is going in for the pOH, and then we're going to solve this equation for the hydroxide ion concentration. So divide by the negative side, we'll get negative 13.2. And then this is log base 10, so it's 10 to the negative 13.2 equals our hydroxide ion concentration, which when you calculate that works out to be 6.31 times 10 to the negative 14th. Okay, let me know if you have any questions, and I will answer them for you.